Hello, everyone, and welcome to this explainer. Okay, let's just jump right in, because today we are looking at a massive structural paradigm shift that is completely reshaping how we think about computing. We're going to trace this transformation from the deepest, most foundational physics of silicon all the way up to the application infrastructure that everyday developers rely on. If you really want to understand where the tech stack is heading and what platforms are positioning themselves to dominate the next decade as prime investment opportunities, well, you're definitely in the right place. To truly set the stage for how big this shift actually is, listen to this quote from NVIDIA CEO Jensen Huang during a recent Stanford lecture. He said, "Computing is being reinvented for the first time as dramatically as it is for the first time really in about 60+ years." What makes that statement so staggering is the timeline. He's talking about the fundamental mental model of a computer, how we architect it, how we write the software, and how we run it. Ever since the IBM System 360 over 6 decades ago, the core principles of computing have largely stayed the same, until right now. So here is our roadmap for today. First, the computing reinvention. Next, co-design and massive scale, followed by the age of agents. Then we'll look at the developer bottleneck, unified app infrastructure, and we'll wrap up with real-world production outcomes. Section 1, the computing reinvention. There is literally a massive divide between the past and the future of tech. In the old era, our computing model was fundamentally based on retrieval. Information, videos, software. It was all pre-recorded. You'd click a button and the computer would retrieve it for you on demand. But the new era? It's fundamentally generative. Everything is generated in real time, which makes it contextually relevant to exactly what you want to do. And instead of just sitting there waiting for your prompt, these new systems are continuous. They're constantly running in the background. That changes every single layer of the stack. Section 2, co-design and massive scale. So how do we actually physically support a system that is constantly generating information instead of just fetching it? Well, to bypass the physical limitations of Moore's law, the idea that chips just inevitably get smaller and faster, NVIDIA pioneered something called extreme co-design. In the old days, hardware designers, compiler engineers, and software devs all worked in their own isolated silos. Co-design means harmoniously optimizing algorithms, frameworks, compilers, and the hardware architecture simultaneously. As Huang pointed out, NVIDIA optimizes everything from the CPUs and GPUs right down to networking and storage at the exact same time. And the result of that extreme co-design? A staggering 1,000,000-fold performance increase over just 10 years. I mean, if we had just relied on traditional microprocessor scaling without changing the software, we might have seen maybe a 10x improvement. Instead, we got a 1,000,000x. Let that actually sink in for a second. 1,000,000 times more powerful. That created this infinite abundance of compute that allowed researchers to process the entire internet's worth of data, which completely unlocked the artificial intelligence breakthroughs we're seeing right now.
Section 3, the age of agents.
Okay, so we've established this unbelievable hardware scale. Now let's look at the revolutionary software systems that this power actually enables. We have completely moved past AI that just summarizes a text or generates a funny image. We are officially in the era of agentic systems. The crucial thing here is that these are AIs that can reason step by step. They generate tokens, think of them as digital building blocks, internally to think and externally to use tools and actually do work. Remember how we said the new era of computing is continuous? Well, these agents operate in swarms, continuously running to solve wildly complex problems, like navigating self-driving cars or managing active cybersecurity defenses. Section 4, the developer bottleneck. Now, this macro vision is absolutely incredible, but let's be real. At the micro level, human developers are the ones who actually have to build the applications that interface with this continuous future. And the reality on the ground right now? It's painful. As computing gets exponentially more complex, software teams are just drowning. They're dealing with fragile handoffs, juggling random spreadsheets to track deployments, and suffering from massive tool fatigue. There's often no clear owner for reliability after a product launches. This high operational complexity slows teams down to a crawl and makes it nearly impossible to build robust apps. But here's the thing. This chaos isn't just a headache. It is a massive market inefficiency just waiting to be solved. Section 5, unified app infrastructure. This operational chaos, it's exactly why a company's stepping up to solve this bottleneck, like Dailey OS, represent the future of the tech stack and, frankly, a highly compelling investment opportunity. Their core philosophy captures the solution perfectly. You should not have to rebuild infrastructure to ship the app you need. Dailey OS operates on the premise that you replace the patchwork of fragile tools with one production system and one accountable team. By providing production infrastructure completely out of the box, developers are finally freed up to focus entirely on shipping their product, rather than constantly reinventing the wheel on the back end.
Dailey OS basically gives you the core infrastructure pillars from day one to build a rock-solid foundation. You've got identity with built-in single sign-on, passkeys, and multi-factor authentication. You have redundant database clusters with automated backups. You get a shared storage network with lightning-fast global delivery through a CDN, and compute powered by Kubernetes, which is the industry standard for scaling apps seamlessly. It literally takes the incredibly complex infrastructure required to run modern apps and standardizes the whole shebang into one unified control plane. And because it's a shared, unified platform, the security and reliability benefits are huge. Notice the standard here. New apps ship with zero plaintext credentials anywhere across the platform. That's absolutely crucial. Every deployment features audited migrations and privileged operations through a centralized ops and vault system. And most importantly, it's all built, hosted, and maintained by Dailey. When you standardize on a system like this, it is easy to see how it drastically lowers operational risk.
Section 6. Real-world production outcomes.
So how does this actually play out? Well, every project built on Dailey OS follows a pretty clear trajectory. You start with an operational bottleneck, usually a team totally bogged down by complexity. Then you map the right system and ownership model using their standardized infrastructure. And you end up with a production outcome that has clearer workflows, far better reliability, and significantly lower risk. It's a direct path from chaos to stability. And for businesses, that translates directly into faster shipping times and lower overhead costs. That kind of operational efficiency is exactly what makes platforms like this such a high-value investment.
To prove this isn't just theory, let's look at some heavy-duty SaaS apps already thriving on this platform. You have Castingly, an app built for the entertainment industry that handles massive, media-heavy casting workflows. And you have Daily Photos, a privacy-first platform dealing directly with giant professional raw image files. Guys, these aren't simple to-do list apps. These are highly complex, data-heavy systems that are running seamlessly, specifically because the underlying infrastructure is rock solid.
Think about what this infrastructure actually unlocks for these apps. They can handle private media delivery without ever leaking raw object URLs. They manage direct, highly secure storage uploads for massive files and automatically generate posters and fast media variants. Plus, they can provide secure share links with complete revocation and analytics. These apps can execute incredibly complex features flawlessly because Dailey OS is handling all the heavy lifting, the foundational compute, storage, and identity layers right behind the scenes. And that brings us to the ultimate takeaway from all of this. We are living through a 60-year paradigm shift. Jensen Huang showed us that hardware has scaled 1,000,000 times over to birth a totally new era of continuously running agentic AI systems. But remember, hardware needs software. Dailey OS shows us that to actually survive this shift at the application layer, teams absolutely have to abandon fragile, pieced-together tools in favor of unified, highly reliable infrastructure. The companies providing these modern picks and shovels are positioning themselves as the foundational, high-value investments of the next decade. So I'm going to leave you with this. As computing moves from on-demand to continuous agentic systems, how will you adapt and invest in your own tech stack to keep up? Thanks so much for joining me today, and keep exploring the future.